All right, guys, recording the second part of the video. Where we start off at number 24 is where we left off last. Actually, before we get to that, we need to do some graphing. So we're going to graph some of these functions by hand. And like I say, when you do the graphs of these functions, we're only doing sine and cosine, and we're only graphing functions that have an a and a b. So we won't have to worry about phase shift or midline shift. Unless you were going to graph something on the bonus, maybe if you had a bonus type question, but we just need to be able to graph them when they have some value for A and some value for B. So we're going to graph a couple of these. I think we'll graph 9, it says graph 10, we'll do 15, and then we will also graph number 16. Now these are just 4 I picked from. If you need to do more of these, you might go to some of the problems we did maybe back beforehand, or you might look at the graphs that we did in class, or you might ask me and I can give you some more to graph if you feel like you want more problems to graph on these. I think we should be able to see what's going on once we do a couple of these though. So let's see, I'm gonna go over to my graph paper to graph this one so we can see just what we're working with, but we'll do number 9, and this one is y equals sine 2x. Alright, so like we say, normally first thing you'll do is the pre-work, the pre-hand work. So we'll fill out these just like we've been doing with the transformations. We see the amplitude here is 1. Our period will be 2 pi over b, and here b is 2, so 2 pi over 2. The 2's cancel, and our period is pi. Phase shift and midline shift are 0. And then the count by. So for the count by, I'll take what we found the period to be, and we'll multiply by 1 over 4. 1 times pi is pi divided by 4. So this will be my count by, meaning we'll go from 0 to pi over 4. Then we'll add another pi over 4 to that, which will give me 2 pi over 4. We'll add another pi over 4 to that, which is 3 pi over 4. And then my fifth and final point will be adding a pi to that, so it'll be 4 pi over 4, which is where my period will finish. So this one simplifies to be just pi. This one, pi over 2. So my count by tells me how I get to the end of my first period. So I'll go ahead and start putting this on the graph. Amplitude, it'll go up to +1 and down to -1. And then I'll do those first couple of points. Let me see, maybe I should use a marker for this one. Let's try this. So these will be my first 4 points. I start at 0 and I'll finish at pi. My second point is pi over 4. Next point is pi over 2. Next 3 pi over 4. And then 4 pi over 4, which is just pi. Since this is sine, I start at the origin. And there isn't a reflection, so I go up first and then I follow the pattern. I keep working my way to the right and just going to the next spot. Amplitude, midpoint, top of the amplitude. And my first cycle is something like this. And then I'll keep graphing it through the point, through the space that I have. And I also need to do it to the left. If you don't finish drawing your graph in all the space that you have, points will be counted off. So just don't be lazy. A graph should go through the whole graphing area. Alright. And that is y equals sine 2 cosine x. Let's do number 10. Number 10, we got y equals -2 cosine 1/4 x. So, number 10, y equals -2 cosine 1 over 4 times x. Make sure I copied that down right. All right, amplitudes first. It'll be 2. It would be negative 2. This negative 2 is actually going to flip it across the x-axis. I don't know why I keep wanting to spell across like that. X-axis. So find the period, 2 pi over b. b is 1/4, so 2 pi over 1 over 4. I'll keep 2 pi and I'll multiply by 4 over 1. So I get a period of 2 pi times 4, which is 8 pi. All right, 0, 0. Count by 8 pi times 1 over 4 equals 8 pi over 4 equals 2 pi. So my count by will be 0, 2 pi, 4 pi, that's the halfway point, 6 pi, and then my fifth point that finishes my period is 8 pi, and that makes sense because that's where my period should end up at, 8 pi. So looks like we're good to go. I'll start labeling things. So my amplitude goes up to +2 and as low as -2. Then my first 5 points are 0. And I finish at 8 pi. So first point 0, second one's 2 pi, third halfway point 4 pi, 6 pi, 8 pi. Since this is cosine, it starts at the amplitude. Normally it would start up here, but we did say it was flipped across the x-axis. That's because of this -2 that we have in front where A would be. So instead of it starting here, it's going to start at the bottom of the amplitude. And then from there, I'll work my way back up. So I'll go over to the midline, I'll go over and up to the top of the amplitude, midline, bottom amplitude, midline, top, midline, bottom, midline. And my graph is something like this. I'll finish it to the left. Oh, not that far. And something like this. It's my graph. Y equals -2 cosine 1/4 x. Right, we'll keep it moving. Number 15, y equals 2 cosine pi over 2x. So this one, y equals 2 cosine pi over 2x. Let me make sure I got it right. Yeah, I think that's it. All right, amplitude's 2, period is 2 pi over b. Here b is pi over 2, so 2 pi divided by pi over 2. I'll keep 2 pi, I'll multiply by 2 over pi. The pi's cancel and I have 2 times 2, which is 4. Mid-shift and midline shift and phase shift are both 0. So for my count by, I found the period to be 4, so I'll take that and multiply by 1 over 4. That's going to give me 4 over 4, which comes out to equal 1. This is going to be a real straightforward count by, just 0, 1, 2, 3, and then at 4 is where I finish my period. All right, check some real quick. All right, amplitude's 2. Do my first 4 points. Since it's not reflected across y, I'll be going to the right. I start at 0, I should finish at 4. So from 0, 1, 2, 3, and then 4. Since it is cosine, I start at the amplitude. It's not reflected, so I stay up here. and then I'll work my way to the right, going to the next location, alternating up, up, down, down. This is my function to the right. I follow the pattern to the left to complete my graph. Hoping I didn't put any spots in the wrong place. So I get there, everything connects, so I think I am good. Y equals 2 cosine of pi over 2x. Alright, and I will turn on the back and do this last one. So number 16, y equals negative sine of 4x. Y equals negative sine 4x. Amplitude will be 1, even though there's nothing there, it's understood 1's there. Period will be 2 pi over b. b is 4, so 2 pi over 4, which can simplify to pi over 2. 0 and 0, and my count by, I take my period and I multiply by 1 over 4. So 1 times pi is pi, 2 times 4 is 8. So my count by is pi over 8. Amplitude is 1. And like I say, it's not important where you put it. Just make sure it's equal distance, and just make sure you label it. I could put 1 up here if I want it. Just as long as you label it, it's fine. We can interpretate what you got for it. So then I'm here. So 0, I should finish at pi over 2. So just to see where these points come from, we got 0, we got pi over 8, and then we'll add pi over 8 to that will be 2 pi over 8. Add pi over 8 to that will be 3 pi over 8. Plus pi over 8 will be 4 pi over 8. And we can reduce this one to pi over 4, and then we can reduce this one to pi over 2, which is where we should finish our period. Alright, so this next point will be pi over 8, followed by pi over 4, then 3 pi over 8, and then pi over 2 is where we should finish. So sine starts at the origin. Since this negative is here, and we should write this, it's flipped across x. So normally my next spot would be to go up here, but since it's reflected across the x-axis, my next spot would be to go down here. And then from here, I will keep following the pattern. Midline amplitude, midline amplitude, mid amplitude. Just like that, and I will work to the left. And that's my graph. So first thing you do is find the key pieces. After you do that, you need to find the count by. That's the additional thing here. And then you'll just apply all that to the graph. Amplitude tells you how high and how low to go. You'll do your count by. If your count by is negative, you just go to the left with your count by. Everything should still all line up. Remember, cosine starts at the origin. Sine starts at the origin. Cosine would start up at the amplitude. If it's reflected, you either start or go down to get you going. And then you don't just graph like a piece of the function. You use the space and follow the pattern and graph the entire thing. All right, and that's graphing our trig functions. All right, so let's see where we're at. Okay, so now at this point, you will have a section where you do some matching on your test. So like I say, we got our 6 trig functions here, and we need to match each one up with this graph. So you might look at your notes to kind of refer to what's going on here if you don't recall. But like we say, each one of these graphs have some distinct feature to where we can remember which one's which. So we've been working with sine and cosine a lot, These two here should be sticking out at you as sine and cosine. They look very similar, except the way they start is the thing that differs. So if I look at this first one, and right here is where I would focus on at 0 radians. Looks like this graph is going through the origin. So I would say this one is sine of x. And just to make a little note of it, because it goes through the origin, alright, so if I knew that was sine, I would say this one was cosine. And if you look right here, cosine goes through the, starts at the amplitude. So I would write that. Let me see, I want to make sure I don't go over any other graph. I would say cosine starts at amplitude. Okay, so that's how I would tell the difference between these two. So this one is cosine of x. Alright, these two look like tangent and cotangent. You just need to know which one's which. And then these other U-shaped ones, one are the reciprocals of sine and cosine, respectively. So maybe I'll focus on tangent and cotangent. So I tell you this one right here is tangent, and I know that because it's got asymptotes at odd intervals of pi over 2. But more importantly, this one's tangent because tangent rises right. So this one would be tangent of x. And I remember tangent rises right. So if I could remember tangent rises to the right, cotangent falls to the right. So this one would be cotangent. So I'd say cotangent x because cotangent falls right. And it's got intervals at at multiples of pi. So 0 pi, 1 pi, 2 pi, 3 pi, 4 pi. Not unlike tangent where it's pi over 2. Alright, so that would leave us with just two more. These two graphs. And like I say, the thing to be looking for here is what is it doing as it crosses the y-axis, the y-intercept. And if you notice, this function right here actually goes through the y-intercept. On this one, it doesn't go through the y-intercept. So this is where x equals 0, we have a y-intercept. And if you remember, these two functions mirror what their reciprocal is doing. So for instance, on this one, if I were to try to somewhat graph it, it would be doing something like this. Alright, and if you notice, it doesn't go through the origin. It goes through the y-axis or the y-intercept. It has a y-intercept, but it doesn't go through the origin. So the yellow graph here would be cosine. So that would let me know it's cosine's reciprocal, which is secant. And I would say it's secant because it goes through y-axis. So that leaves us with this last one, which is sine, because sine would start here, it would go up, it would come down, and they would be touching at these points. And notice how the mirrored function goes through the origin. So this one is cosecant because it does not go through y-axis. All right, so cosecant, tangents graph. We said this one was secant. We said this one was cosine. The one above it was sine because it went through the origin. Then this one down here we said was cotangent. Alright, so refer back to your notes. All you need to do is be able to match these. If we scramble them all up, could you figure out which one's which? That would be your goal for this one. Alright, on to the next section, finding the exact values of the expressions. Alright, so this is just knowing your unit circle, and since we're looking at the inverses, we get our angle measures. And you can write, in this case, you should be able to write either the degree measure or the radian measure. That shouldn't be such an obstacle for us to do now. So either one will work. Let's go ahead and write all of these ones out. And I guess what I'll do is I'll also draw my reference angles, which you won't have to do, but drawing those reference angles, labeling the sides, that's all just stuff there that just helps it all like connect the dots and you can really see and think about what's going on. So we'll do that very briefly. All right, so let's go here. So first one we got is sine's inverse at root 2 over 2. So we got sine inverse root 2 over 2. So remember, sine is in the first and the fourth quadrant. And so for this to be positive, it's got to be in the first quadrant. And I know the coordinates are 2 over 2 at the 45. So I would draw a reference angle. So long story short, to answer my question, it would be pi over 4. Or you say 45 degrees. So now, reason being, because I know sine is 2 over 2 at this angle. So if sine is 2 over 2, cosine would also be 2 over 2 here. And it happens in the first quadrant at the 45 degrees. So my answer would be pi over 4. 26. Sine's inverse at -1/2. All right, so my options are the first or the fourth quadrant. Sine's negative down here in the fourth quadrant. And then thinking about my reference angles, when is sine 1/2? The y coordinate is 1/2 at the 30. So it'd be -1/2 and then 3 over 2. This happens at the 30 in the fourth quadrant, which is at 11 pi over 6. Or you'd say negative pi over 6. All right. 27. Sine's inverse, when the exact value is 0. Sine of 1 of 0. So this is a quadrilateral angle. At 0 degrees, I would be right here. And this is more of a coordinate instead of a triangle, where it would be 1, 0. My answer would be 0 because the y coordinate is 0. If I did like a little fake triangle, because you can't have a triangle that has a side of 0, x would be 1, y would be 0, and the hypotenuse would be 1. So my answer would be 0 because of that. So I say 0 radians or 0 degrees. Same thing. All right, 28. Cosine inverse at 3 over 2. All right, so I'm in the first and the second quadrant for cosine. I know cosine's positive in the first quadrant, so that's the angle I'm looking at. And I know that the x is 3 over 2 at the 30s. So my answer will be 30 in the first quadrant. So this angle is at pi over 6, or you could say 30 degrees. Uh, 29. Cosine's inverse at negative 3 over 2. So it's kind of similar to the last one we did, except the sign changes. So I'd be looking for the 30 in the second quadrant. So 150 is 30 away from 180, so that would be my answer. I would say 5 pi over 6, or 150 degrees. And I know cosine would be negative in the second quadrant at the 30. So this would be my triangle. Negative 3 over 2, y is 1/2. So cosine would be this one. Number 30. Cosine's inverse, I don't know what that was. Cosine's inverse when you get out negative 1. That happens over here where the coordinates are negative 1, 0. So this would be pi. If I were to draw a fake triangle, x, theta, negative 1, 0, 1. 31, tangent. Tangent of negative 1. Tangent's inverse when the exact value is negative 1. Now, if you remember for tangent, you get negative 1 out for tangent when you are at the 45s. So my options would be this 45 or this 45, because that's when tangent equals 1. Since it's negative 1, tangent's negative in the fourth quadrant. So my angle will be the 45 in the fourth quadrant, because the x would be 2 over 2 and the y would be negative 2 over 2. Now tangent is y over x. So after I keep change and flip, I would cancel out and I would get negative 1, since one of them is negative and the other one's not. So this one would be negative pi over 4, or negative 45 degrees. Alright, number 32. I'm recording a video. It's alright, what's going on? You finished? Okay, turn it to there.
Work on the back. I ain't feel like coming to do that.
Alright, just turn it over there to the turning tray. Alright, number 32. We got tangent inverse when you get out negative root 3. Alright, so my questions would be either a 30 or a 60, because I know 45 you get 1. Alright, so since I get a negative value, I know this is going to be the angle in the fourth quadrant. I just need to figure out if it's the 30 or the 60. So my options would either be 1/2 divided by 3 over 2, or I flip them and have 3 over 2 divided by 1/2. What's up, Charlie? You can head out for the game today. So I get 1 over 2 times 2 over root 3. And this is the 60. This is the 30. So the 2's would cancel. I get 1 over root 3. And after I rationalize it, I get root 3 over 3. Here I get root 3 over 2 times the reciprocal. The 2's would cancel, and for this one I would get the square root of 3. So You see the difference between the two. You have root 3 on the bottom for one of them. The 60s, you get root 3 on the bottom. For the 30s, you get root 3 on the top. We want the one that gives you root 3 on the top. So I need the 30 in the fourth quadrant. So something like this. I'd need the 30 where x is 3 over 2 and y is negative 1/2, which would give me this negative root 3. So this happens at the 30-degree angle in the fourth quadrant, which is negative pi over 6 or negative 30 degrees. All right, so remember with these inverse functions, you're getting out angles. You put in an exact value, what you get out is an angle measure. All right, let's look at these application problems to finish things up. All right, so with these application problems, we don't have any pictures, but that's okay. We'll get to draw some cool pictures or some stick pictures and just get a feeling of what's going on. At the end of the day, we want to try to make a right triangle out of the information we have, and we want to label like the corners or the sides, just so we can kind of get an idea of how everything is kind of laid out with each other. And once we do that, we'll be able to like label the sides, figure out which pieces we have, and then we can make an equation and solve it going from there. So let's see, first one, we got a boat on a lake. All right, so let me do this on the paper. So it says, from a boat on a lake, the angle of elevation to the top of the cliff is 13 degrees and 59 minutes. We will need to convert this into decimal form. We'll do that in a second. It says, if the base of the cliff is 1,588 feet from the boat, how high is the cliff to the nearest foot? All right, so let's try to make an image out of this. So let's see, we have a boat on a lake. So I'll make a little lake here. And within that lake, we have a boat. And we'll put a little person on the boat. All right, so we got a little guy on a boat. It says the angle of elevation to the top of the cliff is 13 degrees. So if this is like lake level or ground level, this angle of elevation would be 13 degrees, 59 minutes. Let's convert that to a whole number. 59 minutes is almost a whole hour, so I'm thinking it's going to be very close to being 14 degrees. Probably like 14.9 degrees. So just remember, when you convert, it'd be 13 plus 59 divided by 60. So I just put that in my calculator, 13 plus 59 divided by 60, and I get 13.98. Let's leave it as that. So this gives me 13.98. It's a degree measure. So 13.98 goes right there. And then that's the angle measure. And then it says a cliff, the bottom of a cliff. Says the base of the cliff is 1,588 feet from the boat. How high is the cliff? So the edge of the cliff would be here. If we were to make something that looked like a cliff, maybe the cliff is right here, and then it comes up here. So from the edge of the cliff to right down to the lake, tells me this is 1588. Right, so my image might look complicated. At the end of the day, all we have is this right here. 13.98 degrees.
How you do?
All right, you too. 1,588 feet. And what we want to find is how high is the cliff, this side. Right, so from this angle, we've got adjacent side and we've got the opposite side. So we're using tangent. I'll say tangent of 13.98 degrees equals the opposite side, which we don't know yet, divided by the adjacent side, 1,588 feet. All right, I solved this one for x by multiplying both sides by 1,588. And that's what I will put in my calculator. So x equals 1,588 times tangent of 13.98 degrees. So I'll make sure my calculator is in degree mode. If yours isn't, or if you need to check on these calculators, you hit the mode button, you'll go over to degree, you press enter, and now it's in degree mode, so I'll put 1588, hit the tangent button, 13.98 degrees, and I see that the approximate foot to the whole number is where x equals 395 feet approximately. That's how far it is to the bottom of the cliff, to the edge of the cliff. All right, and that was 33. All right, so let's go 34. It says a building 190 feet tall. I know that, that's straight up and down. So I'll say 190 feet tall, cast a shadow 30 feet long. So the shadow will go this way, and this would be 30 feet. And then it says, if a person stands at the end of the shadow and looks up to the top of the building, what's the angle of the person's eyes to the top of the building to the nearest 100th degree? Assume the person's eyes are 4 feet above ground level. All right, so we're looking from the person's eyes. That really doesn't change a whole lot, other than if we were looking, maybe if the height was like from top of the building to the person's eyes, then we would go from there. But we do need to consider the building is next to the person's feet. And then from eye level, that just changes things a little bit. So I'm going to make a new image, because I guess if we're thinking about this, like the person's eyes are here, his feet are at the bottom of the building, but his eyes are, I'm sorry, you can't see that. So his feet are at the bottom of the building, but his eye level is a little bit off the ground of the building. So it's not really a height of 190. It's 4 feet shorter, because it says this is 4 feet. So maybe a better image would be from here to here. This whole thing is 190, but from here to here is 4 feet. So 190 minus 4 feet would be 186 feet. That's from the top of the building to his eye level. So then, from the person's eye level to the building is 30 feet. So now we got a more accurate image, right? And we want to find this angle of elevation. So we'll say this is x. This is what we want to find. Okay, so looking from this angle, we've got the adjacent side and the opposite side, so we'll use tangent again. So it'll be tangent of angle x. Since we don't know it this time, we'll just let x represent it. It's going to be the ratio of the opposite side divided by the adjacent side. And to solve this one, I need to move tangent over to the right side. So what I'll have is x equals the inverse of tangent using that ratio, 186 over 30. And I'll put this in my calculator. Make sure it's in degree mode. The inverse of tangent when I have 186 divided by 30. This comes out to equal approximately, what are we going to say, 80 feet? Oh, sorry, it's degrees. So this will be, we can do 80.8 feet. I mean degrees, because this is an angle measure, sorry. So approximately 80.8 degrees is the angle of elevation. Right, so the one little weird thing with this one was we had to subtract 4 to account for the person's height from eye level up. So we just subtracted 4 from 190 there. All right, go over to 35. It says a radio transmission tower is 240 feet tall. So here, this is a building 240 feet tall. It says, how long should a guide wire be, which is just a wire from some part of the building that goes diagonally to the ground. How long should a guide wire be if it is attached 14 feet from the top and is to make an angle of 23 degrees with the ground? Okay, so the ground is here, and the guide wire isn't at the top of the building, so the top of the building would be here. It's actually 14 feet below there, so maybe like sticking out a window or something like this, and it goes to the ground, where this is 23 degrees. Okay, and so this is 240, and from the top to here is 14 feet. So when we look at our triangle side really isn't 240. It's going to be 240 minus 14 feet, which will give me a height of 226 feet. So I'll draw another triangle to represent what we really care about. So from here over to here, this is what we want to find, how long the wire should be. I know this angle measure is 23 degrees, and now from the ground to where the wire goes from is 226 feet. Right, so this is my setup. From this angle, I've got the opposite side, and this time we have the hypotenuse. So I say, which function uses the opposite side and the hypotenuse? It would be sine. So I'll set up an equation using sine. Sine of 23 degrees, which we know, equals the opposite side, which is 226, divided by the hypotenuse, which is x. So I want to get x by itself. I'll multiply x to both sides. And then I'll divide by 23 sine to get x equals 226 divided by sine of 23 degrees. And this should give me my answer. So I use my calculator. I got 226 divided by sine 23 degrees. Make sure your calculator is in degree mode. And what I get is about 578.4 feet. $578.4 feet. And I think about the situation and I ask myself, does that make sense? So if this angle of 23, which is kind of small, opens up to be 200 and have a side of 226, this angle would be like, what, 77 degrees, and it would open up to a side that's 578 feet. That makes sense. So this distance should be a lot bigger than this distance because the angle's bigger. So 578 actually does make sense in this case. And this time we did have to use, Sign. I don't think we've used Sign before, so I know some of you guys were asking about that. All right, then we got one more.